Hello everyone, and welcome to tonight's presentation of OTF Connects, using manipulatives for problem solving in the junior classroom with Mary Kay Gowindi. On behalf of Sirius Curhan, who is the administrator and facilitator of the OTF Connects program, and everyone at OTF, we extend our thank you to all of you for joining us tonight, especially when in many parts of the province it's very unpleasant weather. So we hope that you're happy to have the option to stay curled up nice and warm inside instead. And again, we understand that you're here on your own time, and so we're really thrilled that you've been able to join us tonight and are all set to participate with Mary Kay talking about all the manipulatives. And I'm just going to flash our map up here. We've got another great spread right across the province and up into the north, and we love that. So definitely share all this stuff with your colleagues. Let them know about the live sessions, and after tonight's session you'll get an email as well with more information. But right now I want to go ahead and get things handed over to Mary Kay, and enjoy the session, everyone. Over to you, Mary Kay.
Great, thanks, Louise. Sorry about the delay. Sorry that I caused the delay. I hate starting late, but my name's Mary Kay. I'm currently a teacher in Upper Grand. I'm currently a kindergarten teacher. I started the year teaching grade 8 and then was reorganized into an FDK classroom. So I'm having a fabulous year, lots of learning for me. But I used to be the math curriculum leader for our board, so I still do a lot of thinking and reading about math. So just thought I'd offer to do this webinar and share some of my thinking around manipulatives. So the first slide is going to need you to take the polling tool. That was the check mark under your name. And please check yes if the student answered this question right, and check the X or the no if you think they got it wrong. So I'll wait till I see about 18 or 19 responses. Maybe a couple more. Awesome, that's pretty close because I think Louise might be one and I might be the other. So I'm just going to leave this slide for now and we'll come back to it in a second. So here is what the curriculum document says and how the ministry defines manipulatives. Just give you maybe 15 seconds to read this over. And is anything there shocking? Anything there need to be discussed? I expect it's probably what most of you would have given as a definition. Probably not as long and as wordy, but that's what I tend to think of or used to think of when I thought of manipulatives. So keeping that in mind, picture yourself in your classroom and just imagine that you're the student and the teacher has asked you to represent 3/5, as many ways as you can. Just think about what's around your classroom or a classroom you've been in recently, and what might you do to do this task. You can just keep these thoughts in your head if you want. Type them in the chat if you want, but we're not really going to go from here. I've got some images to show you in a second. So you're picturing 3/5. And now put yourself in the position of the teacher, and you're walking past a desk, and you see this on a student's desk. Again, use the polling tool. I'll clear it. Use the polling tool. Yes, they understand 3/5, or they're showing you 3/5, or the X for nope. They don't have the concept of 3/5. So overwhelmingly, yes, that's showing 3/5. And that's probably what we expect. We see the fraction circles are obviously a manipulative that have been manufactured for students to be able to work with the concepts of fractions. So this is the, one of the manufactured fraction manipulatives. But then you go around and you see some other desks. What about here? I was going to say drag the icon over onto the whiteboard, but I'm not sure that's going to work. So maybe just in general. Are these, again, showing the concept of 3/5? Grab the whiteboard, but it does put us all in a bit of a lag. What do you think?
You know what, Mary Kay? I'm going to quickly switch our polling tool to ABC. And folks, I've labeled each of the pictures with an ABC, so you can actually use where the green checkmark polling tool was
awesome.
to do ABC.
Perfect. So I think most of us can recognize how all three of these images actually show 3/5. We have the one straightforward 3/5, so of the 5 locking cubes, 3 are yellow. Then we've got the 10 two-sided tiles. Of those, 6 of the 10 are blue, so that would be 6/10 or 3/5. And then in the other, we've got the 6 rods. And then when compared to, so the 6 blue rods, when compared to the 1 red flat, the blue rods are 6/10, or well, actually they're 61/100, so 6/10, so 3/5. And so these aren't necessarily manipulatives that were created for fractions, but it's easy for us to overlay our understanding of the fraction concepts onto these manipulatives. If we could go back to the yes-no, I think, Louise, for the next slide. Because here's an image. You're walking past, and on someone's desk you see this. Does this student understand 3/5? So I wonder if the, oh, I've got a couple now. If the 1 or the 2 people, maybe 3 now, I see a mark on the whiteboard. If they understand 3/5, if you say yes, this student does understand 3/5, do you want to grab the mic and explain why, or start typing it in the room? Hey, Crystal, long time no talk. So to one of my yes responders, oh, I see. Oh, they're 3/5, but they're not equal fifths. Can you explain that? Because I understand fractional parts have to be equal. Okay, so somebody's saying about asking them, all right, did they mean to grab that blue, or was that they ran out of green? Ah, parts of a whole Crystal's talking about. I can see it, okay. I would say yes. I would actually say yes, this student understands 3/5 because they could say, exactly, Crystal, fractions of a set. I have 5 pieces and 3 of them are green. 3/5 of the number of pieces I have are green. So that is 3/5 of my set are green. And here's the problem with manipulatives. There is no math embedded in the manipulative. The math comes from the concept that the user applies to the manipulatives. So on a first glance, and I did this on purpose, a lot of us thought, no, this child does not understand fractions. but we need to interview them and ask them what they were thinking about, because in fact, by asking a question, of the 5 slices, 3/5 of them are green. That is 3/5. So knowing that, what about this? Does this student understand 3/5, or could they possibly understand 3/5? Sorry, S, I don't know your first name. I don't even know if you're male or female, so I can't call you by surname, but I agree. Sarah, thanks, Sarah. Completely agree, and that's the big part of using manipulatives. And can somebody explain how oh, I'm seeing lots of X's. They don't know what 3/5 is. Does anybody say, I see a possible understanding of 3/5 in here? Okay, I see maybe they're triangles, but triangles to me have to have 3 straight sides. So the corner or that curved side would make them not triangles. And so I would define them all as slices. Some are just bigger than others. 3 of the pieces have 2 sides and a curved side. So that's 3/5. Interesting. Does anybody see another? I'm looking at this and I see that of the 5 pieces, 3 of them show an angle that is less than 180 degrees. So if you did this right after your geometry unit, they'd be looking at angles, and that might be the reason or their explanation. 3 pieces are primary colors. 3 of the 5 are primary. There you go. Yellow and blue make green. That could be a 3 of the 5 put together. Here's the thing. There's no value in the manipulative unless we have a conversation with the student. If we want to use manipulatives properly and have them be so open for thinking tools, then we have to have a conversation. Because I wouldn't want to look at this and assume they understood 3/5 because they maybe have no clue, and I am putting my angle recognition or somebody else's primary color understanding on these manipulatives. We need them to communicate their thinking. Absolutely. Absolutely. So now, go back where we started. How about a polling tool on this? Yes or no? You see B as being 1/3? I don't, A and C. Okay, sorry, I just misread. A and C are correct. I agree. Are they correct in the same way though, Kim? Can you apply the same context to both A and C and have them both be correct? My thinking on that is good. A is only correct if you're looking at parts of a set. So the set model of fractions. Traditionally, when we see images like this, then we are only considering area. So if we are only considering the area, then C is the only correct answer. But fractions don't necessarily have to relate to area. And so a lot of times we have some traditional understanding of what we mean by fractions that the students aren't aware of. And if we want to understand the students' understanding of fractions, then if they see A as a set of 3, that is definitely 1/3. Notice how vague the question is. So I know that we're not on clear questioning, but that is something we do have to consider when we're assessing students. Okay, going on. Maybe just in the chat, you could type, are any of these numbers not represented by the image of the manipulatives that I've put there? I was thinking we could just mark up this as a whiteboard, but if that puts me in lag and holds everybody up,
I'm more worried that the lag's going to actually boot you right out of the session, Mary Kay.
Oh, no.
Well, I'm not seeing it now. You could try it and see if you'd like.
No, I'm okay to just do it this way. I'm trying to check for red bars for everybody, but...
Yeah, I'm seeing lots actually, just with a couple of folks that are on the whiteboard. So if you're using the tool to mark right directly on the whiteboard, guys, usually we love that, but it does seem to be causing some lag for some folks. So we may want to try and communicate in the chat. Thank you.
Okay, so I see a lot are accepting the 126, the 1.26, and the 12,600. And it makes sense that those would be the ones that we easily recognize because we see these as base 10. So anything multiplied by a power of 10 is going to be recognizable to us. What would we want to say to a student who said that this was 162? Are they far away from understanding this representation? Explain that to me for sure. Need to reverse the tens and the ones. Okay, so they counted 6 of the smallest blocks that those of us who know base 10 would call those the ones or the units, and then the rods and the tens. But remember, when students are just building their concept of these manipulatives and trying to link it to their math concept, that's a lot of relationships that the students have to build instantly. And so I think feedback to the child, exactly as, and I'm sorry I lost who said it first, was just, sorry, it was Lynn, need to reverse the tens and the ones. That's a simple conversation with the student to say, you know, what is traditionally thought of. I wouldn't be that upset if a student said 162. Now, I actually see the 31.5 as being possible. Because if I divide my 100 by 4, that makes the flat 25. And then I have, everything is divided by 4, so my ones are then 0.25. So that's 1.5. And then my 20 becomes 5. So that's my 25, sorry, plus my 5, plus my 1.5. So it is 31.5. Why am I dividing it by 4? Because there is no 100-ness to the flat. As long as the flat is 10 times what the rod is, we could stick any number on it. And so traditionally we see the flat as being 100 or a 10 or some kind of power of 10, but it's not necessarily true. And I agree, Annette, it is quite detailed and it is quite meaningful. But yes, I have had students now, mostly in my grade 7 class, so I know beyond the scope of the junior workshop. But when we get into decimals, students absolutely do that dividing. And to divide by 4 or by 25 is quite common because of their understanding of money. And so it's the highlighting of the relationship between the flat and the rod and the unit that's key in the value of this manipulative, not necessarily that it's 100, 10, and 1. That's the power of the manipulative, is that it can be anything the kids need. And I have a lot of students who take everything to money. So dividing it by 25 and dividing it by 4 is very common with my grade 7 class last year, most definitely. basically what we have to remind ourselves is don't say it's wrong just because it's not what we expected. Because a student that doesn't have a strong grasp of base 10 won't use this manipulative the same way an adult who firmly grasps base 10 would use it. And when we hope they do, sometimes that's just a big source of frustration. That's great, Nick, that you've been talking about this relationship in class. Love it. Love the idea of the legend, and that's a way for them to communicate. For sure. And here's the big difference in manipulatives. Van der Waal references manipulatives as answer-getting devices. And when he does so, he's not doing that kindly or favorably. A lot of times when manipulatives are used in class, it's almost the do as I do show. The teacher will demonstrate how to use the manipulative. Well, first of all, the teacher will tell the class which manipulative should be used to solve the problem. And then they will do a demonstration. And then it kind of comes across as the do as I do, and where students just imitate. And we kind of then start to pigeonhole manipulatives for certain strands in math. And also, we almost remove the need for student thought, and we just emphasize the need for student imitation. And our curriculum does not want us to do that. We want to create problem solvers, flexible thinkers, because that's what's going to be needed to be successful in math and just in life in general in 2015 and 2020 and these, these students' futures. Seymour Papert, who I really admire a lot of his work, he refers to manipulatives as thinker toys. And he says that, we should be putting manipulatives just out there as thinker toys. And they may lead us to wrong answers, but they are things that will help us to work out some ideas, because we want students to be constructing their understanding of math. So they have to build, and it will fall down, and they'll build, and then we get in there as teachers, and we help them to refine this constructed knowledge and go forward. And when we use manipulatives this way, it's messy. There's a lot of trial and error for students. They'll grab a manipulative, and then they'll realize, oh, this one doesn't work. And then you as a teacher have to decide, well, do they have to start again? Or is just learning that that manipulative wasn't helpful, is that enough learning for them for that day? Because that's pretty big learning. The other thing about when we use it as thinker toys, it requires students to reflect a lot on the success, on the usefulness of the tool they chose, on the efficiency of it. And that's something we want, right? We want our students to become reflective learners. And so it's definitely, I think, in the line with what the ministry is asking us in terms of the inquiry nature of our classrooms. But as we looked at before, when we use them as thinker toys, we can't just quickly walk down an aisle and look at what's on their desk or on their floor and know if it's a right or a wrong answer without the conversation. The conversation is the key. Absolutely. And with this next slide, I'm showing my age. But these were actually called Tinker Toys, and I don't know if any of you have ever played with these or seen these, but this was a huge part of my childhood, and my grandfather used to talk about these all the time. And so these are kind of Tinker Toys, and you could just build and change your building and rebuild, and you had all these dowels of different lengths and the different circles that you can see with different holes and fans and everything like that. They were awesome to play with. And when I hear about Papert and his talking about thinker toys, I think about tinkering. And I know I'm so happy that Tinker Toys are coming back. Well, they're back to me. I didn't have them for my sons. I feel negligent now. But when I see Tinker Toys, I think of it makes me connect to the whole inquiry push in the province of Ontario, and the what-if questions, and the wonder, I wonder, and definitely leads me to problem solving and inquiry. But my question is, how comfortable are students at tinkering? And how comfortable are students at trial and error? Especially if they have gone through a math experience where manipulatives have been used as answer-getting devices. Because, you know, why would I tinker with something and mess around if it might get me to the wrong idea? Why don't you just show me how to use this, and I will get you the right answer? And my comment to students who ask me that is, because you will only need this one answer this one time. I want to create some skills with you that you can solve any problem anytime, or at least more than one problem at more than one time. We have to break that answer-getting culture in math class for sure. We still absolutely want accuracy and proficiency with calculations, but we need to break some of this answer-getting. It's about speed, and it's about only the right answer. Sometimes it's about getting the right answer slowly through trial and error, because that's that kind of learning that you can't forget. We have kids that forget their times tables or forget the area of a parallelogram formula and things like that. But when they really build it slowly and they build that conceptual understanding through tinkering and thinking and reflecting and trying again, that's the kind of knowledge that we want these students to have. It's called relational knowledge or relational understanding, because you have so many connections in your brain, you can't possibly forget it. I see lots of things that I'm loving here about the open-ended and mistakes are learning experiences. I agree. I think, Sarah, that they do have a hard time applying the manipulatives. And that's the problem even when we do the demonstration, is because we are demonstrating with the manipulative our understanding of the math concept. But I have lots of students who understand math very differently than I do. And I often say, like, I'm going down a road that might be at a 90-degree angle to their understanding. So not only they have to come backwards on their understanding and then go forward down my path when they may have been only one step away from figuring it out on their path of understanding. Absolutely difficult to structure a math program that puts all these things in play. Teaching math is very hard. Teaching anything is very hard, because we know now we can't just tell them and have them remember. We have to have situations excuse me, that bump the students against the big ideas of math, which is hard because that means that we really need to understand ourselves what the big ideas in math are, and not just procedural understanding of them, but that deep conceptual understanding, so we can recognize when a student is getting close in their tinkering. Really, really difficult. Really difficult to do. Anybody want to grab the mic and say comment at this point, or have a chat?
I'll jump in and mention something. When you were saying, Mary Kay, about you know, the more brain connections that are happening, I actually learned a totally parallel story that I think makes perfect sense as well, to understand how important that is, especially when their brains are growing at such an incredible rate, and the more and different kinds of synaptic connections they can make, the better. I have a friend who's got some blood clots in her lungs, and she's a few years from retiring still, but it went undiagnosed for a very long time because she was an elite athlete throughout all her university years and has run. She's a runner, been a runner her whole life, and she had all these extra capillaries that were protecting her lung, and they said that saved her life. So it kind of makes me think of math in the brain.
Absolutely. Geez, scary thing for her health. Anybody else making a connection? I'm back in my basement. I can just keep talking, so feel free to interrupt. And I agree, Sam, it is a challenge. Absolutely. And they have been, it's almost learned helplessness. I will just sit here and wait for the teacher to show me how to get the right answer. But what they don't see, it's the right answer to this one question. And a lot of us learned math rotely or through that kind of teaching model. But I think that we have to remind ourselves that we became teachers and might not be representative of the students in our classrooms. So those in our classrooms that are going on to be teachers may learn that way. But we have a lot of different styles of learners or different skill sets in our classroom, and that model won't necessarily work for them. And I think back to my own classes, there were definitely some kids that struggled with math forever. And I wonder if maybe a different teaching style would have changed that for them. Absolutely. Isn't it humbling when a student understands something in a way that you did not understand it, Nick? And it is just mind-blowing. I had a student develop a formula, and I've never had this happen. 23 years of teaching happened 2 years ago. A student came up with a new formula to calculate the area of a trapezoid. It involved breaking into 3 triangles, and all they needed was the base and the height. And I was just blown away because I'd never seen it. Obviously, they understood triangles in a more conceptual way than I did, and I was just floored. I always did the top plus bottom divide by 2 times the height, and they did something totally different. I was like, wow, I'm shocked that a grade 7 student did that. Here you go. I took this picture. I couldn't find the image, and I just thought I'm going to take a picture of it. So this is from page 31 of Vanderwaal's book, and you might not have that exact copy, but this is, as an aside, this is a book that I think that if you're teaching math, you might want to get your hands on if you haven't seen it. Marion Small's books are very similar. I did my math with the Vanderwaal, so that's what I'm more partial to. But if you just take a minute and look at this diagram, it's about all the connections that happen. And when we use manipulative models, all the kind of strengthening representations it builds. And this is from 3 researchers, Lesh, Post, and Baer. And they were studying students and their understanding of how to translate from a picture to a manipulative, or from a manipulative to a written symbol. And you can kind of figure out the rest there. And they found that students that had difficulty translating, so difficulty with any of these red arrows, struggled in math, both in their computation and in their problem-solving skills in the domain of math. Vanderwaal goes on, and I'll just read right out of his the book. He said, the more ways children are given to think about and test an emerging idea, the better the chance it has of being formed correctly and integrated into a rich web of ideas and relational understanding. So that just calls upon us the need to have manipulatives and manipulative models in our classrooms, because if we remove it, we are hurting or impairing, maybe delaying, students' conceptual understanding of mathematics. My favorite, No Debbie. Okay, I need to come back here and see this because I don't know what that is. Oh, my favorite number. Okay, get it now. Sorry, I'm multitasking, probably badly. And then when I looked at this picture, what I put on top here is what sprung to mind. Anybody see the connections between the top of the slide and the bottom of the slide? I see some typers. And that, yeah, those are the math processes right out of the Ontario curriculum. So if you're teaching math in Ontario, it is necessary, it's a must, that we are coaching students on these math processes. So this is part of our curriculum, so it's part of what we signed up to teach and coach our students through. It's actually the first page of any grade, and if you haven't looked at the curriculum closely, this is my favorite page of every grade level, because it's how we coach the students to improve their math. So I always think of it that I coach on the processes, and I do that via the specific and overall expectations. So that is kind of the plays that I run are the expectations, and I'm coaching by using the processes. But absolutely, it goes right back to those 5 representations of math ideas. It's very hard not to see any of the processes in there, except perhaps reasoning and proving, although you'd need strong oral language to do that. So even that I see as being embedded in that image that I found in that Vanderwall book. So I've been talking a lot. Thank you, Louise, for tracking down that link. I'll definitely look at it. I'm going to watch a video now, and the video is actually 8 minutes and 40 seconds long. Maybe polling tool. How many of you have seen this video? This is actually Doug Clements, and it's in the context of early math, but it's on integrated concrete concepts. See one yes, but mostly no. So if you have, and it's been a while, you might want to watch it again. I see it was Crystal, maybe at the summer, Crystal. And if you haven't, take the time. Now, at 6 minutes and 38 seconds, he actually switches over and he starts talking about the learning trajectories. Not bad to watch, but not exactly related to the whole notion of manipulatives. So why don't, if Louise can put it up in the, either the link in the chat, here comes in the web tour, and just mark a yes when you have seen enough of this video, either you remember it from before and you're not going to rewatch it, or you've watched to the 6:38 when he talks about a slightly different topic, or by all means use all 8 minutes and 40 seconds and watch the whole video, and I'll rest my throat and we can talk about it after.
Okay, perfect. I'm going to post the link in the chat, and I'm going to post it right here in the whiteboard space, which is now a web tour. If you don't see anything show up in that space, then click on the link in the chat. It's okay, either way is going to work, but as soon as I hit enter here, the video is going to start playing automatically, and it may be louder than your current volume. Or it doesn't start right away. Hang on, maybe it's just my computer. Oh, okay, you may need to click on this one. So the very top video there. Or is it? Know what, Mary Kay, double check with me here and let me just look down the list. Oh, no, it's the 4th video down. Yes, so you're going to need to scroll at the right-hand side of your screen and select the Integrated Concrete Concepts video.
Okay, so just for the sake of time, I'm going to go on because I think you probably all saw enough of the integrated concrete concepts part of that video to make sense. And as Louise said, you'll have the link, or you can bookmark it, or you'll know how to go back and find this anyway. Any comments beyond what has already happened in the chat? I know some of us maybe finished early. Nice connection. I do like Arthur Hyde's book. And I agree. I see those connections too. Concrete and digital, yep. And the thing that I really liked too was his distinction between sensory concrete and then integrated concrete when he was talking about breaking off a number. And I think that because this is a junior scope presentation, I guess, it's maybe that integrated concrete that we want students to start to go into, because when we've got students you know, working with 5-digit numbers, they're not pulling out 50,000 cubes.